Welcome to the first example of determining the difference quotient for a given function. This quotient here is called the difference quotient, and while it might seem random at this point, this is actually a very useful quotient. If we knew the value of x and the value of h, it would give us a slope of a secant line to a given function, and in calculus, when we take the limit of this function as h approaches 0, it actually gives us something called the derivative of a given function. But for this example, we're just practicing the algebra. So to start, we want to find f of the quantity x plus h, which means for our function f, we're going to substitute the quantity x plus h for x. So we would have 2 times the quantity x plus h minus 5. So all of this is f of the quantity x plus h. Let's put this in parentheses. And now we have to subtract f of x. So we'll subtract the quantity 2x minus 5. And now we'll divide all of this by h. Now let's begin to simplify f of the quantity x plus h by distributing 2 here. So we'd have 2x plus 2h minus 5, and then minus the quantity 2x minus 5 divided by h. And now we're going to clear the parentheses and simplify the numerator. So to clear the first set of parentheses, we'll think of distributing a positive 1, which won't change anything. But then for the second part, because of the subtraction, we can think of distributing negative 1, which will change the sign of each of these terms. So we'll have 2x plus 2h minus 5. And then distributing negative 1, that would give us minus 2x. And negative 1 times negative 5 is positive 5, so we have plus 5. So it is important that we have these parentheses here to make sure we subtract the entire function f of x. Now let's simplify the numerator. We have 2x minus 2x, that's 0. We also have negative 5 plus 5, that's 0. So this simplifies nicely. We have 2h divided by h, but h over h simplifies to 1. So our difference quotient is equal to positive 2. In example 2, we'll find the difference quotient for a quadratic function. I hope you found this helpful. Welcome to a second example of determining the difference quotient for a given function. In this example, the given function is a quadratic function. And as mentioned in example 1, this difference quotient, or this quotient here, is a very important quotient in the study of calculus. But for this example, we're just working on our algebra skills to simplify this quotient. So to start, we want to find f of the quantity x plus h, which means the quantity x plus h is the input into the given function. So wherever we see x, we'll replace x with the quantity x plus h. So if f of x equals x squared minus 3x plus 4, f of the quantity x plus h would be, instead of x squared, x plus h squared. And then instead of minus 3x, we'll have minus 3 times the quantity x plus h plus 4. So all of this is f of the quantity x plus h. Let's put this in parentheses to keep things clear. And now we still have to subtract f of x, so we'll have minus the quantity x squared minus 3x plus 4. All this is divided by h. Now we're going to multiply out f of the quantity x plus h, so we'll start by squaring the quantity x plus h. There's no shortcuts here. If we want to square the quantity x plus h, we'll have 2 factors of x plus h. When multiplying these binomials, we'll have 4 products, 1, 2, 3, and 4. So x times x is x squared. X times h is plus hx. H times x is another plus hx. And then finally plus h squared. So we'll have x squared plus, we have 1hx plus 1hx, that's 2hx, plus h squared. which means f of the quantity x plus h would be x squared plus 2hx plus h squared. And now we'll distribute negative 3, so we have minus 3x minus 3h plus 4. And we still have minus f of x, so minus the quantity x squared minus 3x plus 4. This is still divided by h. Now we'll clear the parentheses in the numerator and combine like terms. So if it's helpful, we can think of distributing a positive 1 here, which won't change anything, but because of the subtraction, we can think of distributing a negative 1 if that's helpful. For the first part, we would just have x squared plus 2hx plus h squared minus 3x minus 3h plus 4. Notice nothing changed. But for the second part, if we distribute negative 1 or subtract this entire function, it's going to change the sign of each term. So we'll have minus x squared, and then negative 1 times negative 3x is plus 3x, and then negative 1 times positive 4 would be minus 4. Now looking at the numerator, notice how we have x squared minus x squared, that's 0. We also have negative 3x plus 3x, that's 0. And then we also have 4 minus 4, that's 0. So we're left with 2hx plus h squared minus 3h divided by h. But we're not done yet. This does simplify further. Notice each term in the numerator contains a common factor of h. So we're going to factor out the common factor of h from the numerator. That will leave us with h times the quantity 2x plus h minus 3, still divided by h. But now we have h over h that simplifies to 1. So our simplified difference quotient is just 2x plus h minus 3. Okay, hope you found this helpful. Thank you for watching. Welcome to a third example of determining the difference quotient, or this quotient here, given a quadratic function. So for the first step, we want to determine f of the quantity x plus h, which means x plus h will be the input into the function, so we'll substitute x plus h wherever we see an x. So instead of 3x squared, we'll have 3 times the quantity x plus h squared. And then instead of minus 5x, we'll have minus 5 times the quantity x plus h. And then we have plus 2. So this is f of the quantity x plus h. Let's go ahead and put this in parentheses to keep things organized. And now we'll subtract f of x. So we'll subtract the quantity 3x squared minus 5x plus 2. It is important that we have these parentheses around f of x so that we make sure we subtract the entire function. And all this is divided by h. Now we're going to multiply out f of the quantity x plus h. So let's first find 3 times the quantity x plus h squared. Let's go ahead and do this on the side. 3 times the quantity x plus h squared is equal to 3 times the quantity x plus h times the quantity x plus h. Let's go ahead and find the product of the two binomials first. So we'll have 4 products, 1, 2, 3, and 4. So we have 3 times x is x squared. The next two products will be like terms. We have x times h, that's hx, plus h times x, that's also hx. So we have plus 2hx plus h squared. And now we'll distribute 3. So we have 3x squared plus 6hx plus 3h squared, which means we would have 3x squared plus 6hx plus 3h squared. Then we'll distribute negative 5, so minus 5x minus 5h plus 2. Again, minus f of x all of this is still divided by h. Now for the next step, we'll clear the parentheses and combine the like terms in the numerator. So if it's helpful, we can think of distributing a positive 1 here, and because of the subtraction, we can think of distributing negative 1 here. So no signs will change in this first set of parentheses. But when we distribute negative 1, it's going to change the sign of each of these terms. So we'll have minus 3x squared. Negative 1 times negative 5x is plus 5x. And negative 1 times positive 2 would be minus 2. All divided by h. Now looking at the numerator, we have 3x squared minus 3x squared, that's 0. We also have negative 5x plus 5x, that's 0. And we have plus 2 minus 2, that's 0. So we're left with 6hx plus 3h squared, and then minus 5h divided by h. But we're not done. Notice how each of the terms in the numerator contains a factor of h. So now we'll go ahead and factor the numerator to simplify. If we factor out h, we're left with 6x plus 3h minus 5 divided by h. In this form, we have h over h that simplifies to 1. So the simplified difference quotient would just be 6x plus 3h minus 5. I hope you found this helpful.